You guys have been learning how to balance reactions, but now what I want to add on top of that is trying to determine what type of reaction it is. And so we have five types of reactions that we're going to talk about today. And the first one we're going to talk about is synthesis. And so I'm going to go ahead and zoom in on this. Now, this may look like a lot. Don't overthink it. So when you think about a synthesis or a combination reaction, what I want you to write down, it starts with two reactants, it ends with one product. Okay? And so if you remember in the notes, your reactants and products are separated by the arrows. Okay? So everything to the left of this is going to be my reactants. Everything to the right of the arrow is always my products. And so here is how you know it's a synthesis reaction. You're always going to start with two products. So notice I have iron plus sulfur, that's two. In this one, I have copper plus oxygen, that's two. Okay. Now, there are more complicated ones, but don't overthink it. Okay. If it's separated by a plus sign, that's telling you there's two reactants. So now I have a compound and an element, but it's still separated by a plus sign. So here is one reactant, here is the second reactant. All right. And you may even get one that might be two compounds, and that's okay. Okay. So you have two reactants here, and they're separated by a positive. You have one and two, one and two, one, two, one, two, one, two. Now, notice at the end, there is only one product. There is no plus anything. It's just one thing. All right. And so this is how you know it's a synthesis reaction. You start with two products. So here's one, here's two, or sorry, you start with two reactants, and then you end with one product. So again, we have one, two reactants, we have one product. Okay, looking over here, we have one, two reactants, one product. Again, we have one, two reactants, we have one product. Last one, two reactants, one product. Okay. And so you're never going to have to actually give me what it actually makes. It'll always be written out for you like you see. You may have to balance it. That's it. But you should be able to identify its synthesis by having two reactants, and after the arrow, you have one product. That is what tells its synthesis. Okay. The next type of reaction is we have decomp. It's the opposite. Think about decomposition. Okay. Bananas, fruit, anything decomposes. So if you think about it, they break down. It's the opposite of synthesis. So you're actually going to start with one reactant and you're going to end with two products. So again, I'm going to separate it by the arrows just so you can see. If you notice before the arrow for all of them, I have one reactant. Okay. And at the end, I have two products. So I have mercury and oxygen for this one. I have hydrogen and oxygen. And notice they're separated by a plus sign. That's how I know there's two products. Okay. And if we continue looking, we have two products here, two products here, two products here. So just to reiterate, synthesis is two reactants, one product. Okay, so two before the arrow, one after the arrow. Decomp is the opposite. It's one reactant, two products, or one before the arrow, two after the arrow. That is all you're looking for to say if it's synthesis or decomposition. Okay. When we go into single reaction or single displacement, these are a little trickier, but I've gone ahead and wrote something down for you guys so you guys can try to know what to look for. Okay, so up here in red, you're going to have two reactants and you're going to have two products. So if you notice, I have two reactants and I have two products. Okay, and that's going to be for everything that you see. Now, here's the thing, and you're going to know that it is single displacement. It's going to be a compound plus an element plus a new compound plus an element. So you have a compound here, you have an element. This zinc is actually going to replace one of the elements. So you get zinc with SO4 as opposed to copper with SO4, and now copper's by itself. So if you notice, my compound to start with is different from my compound to end with, and I have a new element and a new element. All right? So just remember, it is a compound plus an element, and then you're going to get a new compound because this magnesium is going to replace one of the elements, and then that new element that was replaced is going to be by itself. So magnesium replaced hydrogen. So if we look after, or my products, my hydrogen's now by itself, and magnesium took the spot of hydrogen. Okay, so once again, I have potassium and iodine, and I have a compound chlorine. Then I have potassium chloride, so chlorine replaced iodine, so now it's potassium chloride, and iodine's by itself. So just remember what you're looking for is you're looking for two reactants and two products. So you notice I underlined two things on each side, but it's going to be a compound plus an element. And then at the end, it's going to be another compound plus an element. All right. And so the element that starts is just going to replace one of the elements in the compound. And so you can kind of see which one it replaces. So zinc replaced copper, and now copper's by itself. Magnesium's going to replace hydrogen. So once again, it replaced hydrogen. Now hydrogen's by itself. And then chlorine replaced iodine. So it's potassium chloride, and now iodine's by itself. So that's how you can tell that it's a single displacement. So the element is going to replace one of the elements in the compound, and the element that it replaces is now going to be by itself. Okay? Double displacement, it is almost similar to single displacement, but now you're going to have two compounds, and it's going to be two compounds in the product. Okay, so before, for single, it was a compound element. For a double displacement, it's going to be a compound and compound, and it's going to be a new compound and a new compound. Okay, so you guys can see that silver is going to bond with chlorine, and then I'm going to put a new color. Sodium is going to bond with NO3. And so you can see sodium and chlorine are together now, or silver and chlorine are together now, and sodium and NO3 are together now. Okay. So if I look at the next one, barium is now going to replace with SO4, and sodium is now going to switch to chlorine. So if we look, BaSO4, and then you have sodium and chlorine. Okay, and so they're double replacing each other. They're both replacing each other for the other element or polyatomic ion in the other compound. And so the easiest way to remember this is it's going to be two compounds, and it's going to end with two compounds. And if you look at the compounds, you notice they've switched with each other. All right. And so that is what you're looking for double replacement. Okay, so if you need to write this down, two reactants, it's going to be a compound plus a compound, and then the two products, it's going to be a new compound and a new compound. Now, my last one is going to be a combustion reaction. This is the easiest. Okay, it is always, always, always going to be a hydrocarbon plus oxygen, and it's always going to produce water and CO2, and it doesn't matter what order it goes in. The CO2 can be in front of the water, okay, or the water can be in front of the CO2, but just know the water and CO2 are going to be the products. The hydrocarbon and oxygen are always going to be the reactants. So if we look, we have an example here. CH4 is my hydrocarbon plus O2, and once again, it's H2O plus CO2. Another example, Notice it is a different number of carbons in hydrogen, but it's still a hydrocarbon plus an oxygen. And once again, my products are water and CO2. And so combustions are usually the easiest to spot out because they're always going to be relatively the same. The only thing that ever changes is my hydrocarbons right here. All right. And so for your worksheet that you guys are going to be doing is you're going to still be balancing your reactions, but now I want you to try to tell me what type of reactions they are. Okay. And so to reiterate, we have synthesis or combination reactions. We have decomposition reactions. We have single displacement or single replacement. They mean the same thing. And then you have double displacement or double replacement reactions. And then the last one is combustion. Okay, and if you have any questions, just send me an email. Okay, other than that, go ahead and balance your worksheet and tell me what type of reactions there are.